I need to go. Hey, Mom! The meatloaf! We want it now! The meatloaf! Mom, the meatloaf!
Always great to start off with the Will Ferrell scene for geometry class. But anyway, we're on 4-6, congruence in right triangles. So let's see. We have the hypotenuse here and two different legs here. So our goal, our learning target, is to prove right triangle is congruent by the HL theorem. And you could guess H means hypotenuse, L means leg. So again, as I mentioned, the hypotenuse is the longest side of a right triangle. So always directly across from the right angle. See, directly across. And then the legs are the two sides which are not the hypotenuse. Simple as that. Alright, again, hypotenuse leg theorem, HL theorem. If the hypotenuse and a leg, notice just one leg, of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So there's a few conditions here. There's 3 conditions that must be met. First one, and probably the trickiest one, as far as it goes in proofs, there are 2 right triangles. So again, you might be given information that they're perpendicular. You're going to have to go through a bit of a process to show that the 2 triangles are right triangles. So just be careful there. We'll go through some examples in a bit. Then these are just sides. The triangles have congruent hypotenuses, and there's one pair of congruent legs. So that should be pretty easy. So here, which 2 triangles are congruent by the HL theorem? Let's see, we need right triangle. So this has a right triangle, it's a right triangle. This is a right triangle, this is a right triangle. So we're good with the first condition. Then the hypotenuse must be congruent in each triangle. So let's see, here the hypotenuse is 5. Here the hypotenuse is 5. Here the hypotenuse is yeah, I'm not sure. So this one wouldn't be congruent with the others, and let's just make sure one of the legs are congruent, 3 and 3. Okay, good. So this triangle LMN, and let me name it in the correct order, OQ, since I said LM, OQP. So LMN and OQP are congruent. Alright, so here's one of those proof things that we do. We're given that CD is congruent with EA, right here. So that's good. We have the, what's that? The hypotenuse or leg. It's across from the right triangle, so that's a hypotenuse. And then AD is the perpendicular bisector of CE. So that word perpendicular bisector, that's going to give you 2 pieces of information. Bisector of CE, that means that CB will be congruent with EB. And you could see that by the 1 tick mark there. So again, given information, let me go back. This will be given, we know. And then the tricky part is going to be figuring out how to say the right triangles. So we saw that, all right, they're perpendicular. What does perpendicular mean? Well, if 2 things are perpendicular, they have right angles. So that's all you could say next for number 2. Just be careful with that. Again, so for number 2, you could say the 2 angles there are right angles by definition of perpendicular. And have we shown that they're right triangles yet? No, we haven't, obviously, because we just said they're right angles. But good news is we can say that next. The 2 triangles are right triangles by definition of right triangles. Because what does it mean to be a right triangle? Well, it has right angles. So simple as that. So again, just notice the process to show that they are right triangles. Be careful there. And then next, CB congruent with EB. We said that was by this word, bisector, because it's bisecting the segment. And then how we, all three conditions yet, right triangle is good. We said hypotenuse was congruent, and then leg congruent. Good. So the two triangles are then congruent by HL theorem. Nice. All right, next one and last one for the day. We have angle PRS and RPQ, here and here, are right angles. And then SP is congruent with QR. So what I want you to do, take a look at this and see if you could figure it out. Do we have right triangles? Basically, we know they're right angles, so therefore they're right triangles. Do we have hypotenuses congruent? Yes. And then is there a leg we could figure out that's congruent? Well, I think I see a side that's shared here. What do you guys think? Yeah, well, yeah, if it's a shared side, then PR is congruent with PR by reflexive property. So just take a look. Given. Again, we have to show right triangles. So yes, by definition of right triangles, since they are right angles. Then PR congruent with PR, and then the triangles are congruent by HL theorem. Very good. Alright, excellent job. You did a great job listening today. I look forward to explaining more in class tomorrow. Thank you.